All right, welcome everybody. Welcome to this session about Visual Studio Team System Database Edition. My name is Kurt Drapers. I'm the engineering manager for the product. And I'm honored today to actually go through an overview of our product. So what I want to discuss during this session is some of the fundamentals that lay underneath our product, also known as declarative database development. I want to take you through is like versioning your database schema and how you can actually use our product to version your schema and incrementally deploy this. How this in the next release is going to contribute to a heterogeneous environment that also will enable you to use the same tool set but then with other databases. And then we're going to spare a fair amount of time at the end actually extending the environment and writing actually some code, because at the end of the day this is still PDC, right? So all right, so here we go. So first of all, it's like why make something different, right? And in order to go through that exercise, like I would like to take you through the versioning challenge and compare and contrast the regular work that an app developer would do and compare that with a database developer. Now this is a very simplistic example, but it's like hopefully it's like after these slides we're all at the same page. So first of all, it's like if you go to the versioning exercise and it's like you're writing your code, doesn't matter if this is C# or Java or C++, you write your class definition and you check it into source code control. All right. So if you're a database or data tier developer or you're a DBA, depending on what your label is that you put on yourself, you're the data dude, you write a create table statement. Okay, so that's like, well, that's basic. Come on. Move on. All right, so version 2. Well, in version 2, it gets interesting. All right, the app tier developer simply adds a piece of information to its class or removes it, where it's like the data tier developer actually has to deal with changing state. All right, and this is the part that most developers, and sorry if I offend you here, don't understand. Right? A database is a stateful engine. You cannot simply drop something to it and say, it's like, here, deploy it. Oh, it was wrong, roll it back. All right, so you're dealing with state changes here. So in this case, it's like we want to add a primary key constraint. Next version, we want to add a unique key constraint. Now you say, okay, well that's trivial, dude. It's like, move on. It's like, why would I bother? Well, how are you going to deploy this? So most of you will probably write something like this. For how many of you is this familiar code? So a lot of you actually have to write, or it's like you either use a tool to write it, code like this that says like, all right, if the object does not exist, go do this. If the object does exist, go add something, add some other state, go from state transition to state transition to state transition. Now, what is the problem with this? Well, A, it's labor intensive, right? B, it's like, it's error prone. Because it's like you need to know is like what cycle are you getting into, and can I make the right detections actually in the system to do the right actions? And last but not least, actually, this is not really performant, right? Because like all these checks that you have to do at the end of the day, they add up, and these scripts can get really verbose. And to just give you anecdotal evidence, it's like the reason why service pack installs in SQL Server 2000. For example, in 2005 took so long was because of this. Right? If you look at the update inst MSDB script, it's full of this stuff. All right? Check if we already did this, change the table, move all the data around, etc. Okay, so let's look at an alternative. So when we go look at the alternative, we are going to make the same comparison, but we're going to do that from the point of view of using our product. So in the first release, like nothing changes, right? The user defines the shape of the object that he wants. However, in the second part, it's like the data tier developer is now, instead of going to write the alter statement to actually change the state, he's only going to express the shape that he wants. And so does he in the third release, where he adds the definition of the unique constraint in this case. Now you would say, it's like, well, hold on. Now my source code controlled version, I cannot really deploy anymore, right? It's like my deployment script and my source code control scripts are going to differ. So I can do a great new installation from here, but at the end of the day, it's like I cannot no longer do an incremental deployment. So this is where our deployment engine actually steps in and will help you out. So let's walk through how we're going to deploy version 3 in this simplistic example. So first of all, the user has this definition. That's what he wants to deploy. Deployment engine says, like, all right, where are you going to deploy this to? Well, let's take the easy case, empty installation or new installation. Of course, we're going to do the whole create table, easy case. The second one is we're going to look at the target database and figure out, it's like, hey, you need to, in this case, we already have the table, primary key is already there. We only need to add the alter or the unique constraint. So the simplest way to get there is by altering the table. So what the deployment engine does, it takes the shape definition in, compares it with the target instance, and figures out the deployment script. Now in this very simplest example, that is like trivial. But in a realistic environment, it's like you have to deal with all the relationships between all the objects. If you have schema-bound views, you need to make sure that you're binding and unbinding things in the right order. If you're changing indexes, it's like you need to do this in the right order so you don't rebuild your indexes multiple times. All these kind of aspects are taken into consideration by the deployment engine. The deployment engine is fed through this declarative definition of how you want your schema to look. So instead of defining how you get there, we ask you to define what the shape is. We ask you not to worry about how to mutate your schema or to create your schema, but simply define, this is what I want. This is the schema as I want it to look like. Okay? We ask you to express this through a well-defined domain-specific language. And we all share the same language here, which is T-SQL. So we took the T-SQL language definition and said, it's like, all right, define the shapes of those objects. Those object definitions reside in .SQL files because like when we were building this product, we were actually going off and pushing it all into XML. And then we showed it to a bunch of you. And you said, it's like, are you nuts? It's like, I want this to be usable with existing tools like Query Analyzer, SSMS, SQL, OSQL, etc. So we want this to be stored in a well-defined format. So .SQL files it is. Those shape definitions are then used to actually create a model representation. So what we do is like when we open up your project, we read all your .SQL files and create a model representation that we are going to then use to represent your schema. So we can do things like round trip your source code version into a model, and from model back to source code, and from source code back to model. So that way, it's like we can have designers and other tools work on top of the model. We can generate those artifacts as part of it. And one of the most important artifacts, of course, that we can generate is the deployment script, and we'll get to that in a moment. Okay? So all of this is encapsulated within the database projects. So the database projects is the overall facility that we added to Visual Studio in 2005 when we started this project, and is the foundation of the database project functionality. So there are three main pillars of functionality that are offered through database projects. Managing change. This is built on top of the schema representation, so it allows you to version your schema, incrementally deploy, but it'll do also things like schema comparisons and schema refactorings, and I'll show you that in a moment. We also added tooling that is available for the app tier developers, like unit testing and test data generation. And we integrate all of this into the application lifecycle. Now, a lot of people ask the question, is like, are you therefore bound to using Team Foundation Server? No, you're not bound to, but you definitely have a lot better experience and more functionality if you're part of that world. But it's not a mandatory piece of integration. Now, today, as I said, it's like we already were working on this like since 2005. We've released in 2006. In 2008, we released. And today, we're actually proud to announce that just an hour ago, talking about agile development, we released our first release candidate of the GDR. The GDR is our update to actually help the SQL Server 2008 release by supporting them inside Visual Studio 2008. So what we've done is, thank you. So what we've done is we actually building on top of Visual Studio 2008. So for some of this might be like, well, these are existing bits. That's not sexy. Well, it's available. That's why it's sexy. So we're building on top of SP1. The reason for that is that we need the connectivity to SQL Server 2008. We're enabling the support for SQL Server 2008 as a result of that. And we're introducing a lot of the Rosario functionality that were slated to go out way later than this, actually in this release. And the three major changes are that we're building this on the schema provider model. I'll talk about that in a moment. We're separating out build and deployment. We'll talk about that as well. And we're adding a lot of public extensibility so you can actually take the product and make even a richer environment out of this as well. As you might know, it's like we have been shipping Power Tools over the last couple of years. And what we've done based on the feedback from you users, we decided which ones actually became features and which not. So for example, T-SQL static code analysis was widely received by you guys. The biggest question is like, how can we write our own rules? So we added the functionality and the ability to write rules. Dependency viewer also added to the product. And then it's like we've made many, many more enhancements with regards to organizational structure, how we build into team build, for example, and many more things. And like if you want to see that, it's like stop by at the booth. I'm happy to demonstrate this to you. So let's talk about some of the key architectural changes. So first of all, it's like, as I said, it's like we made everything model built. So why is this such an important thing? For those of you who worked on the previous releases, you know that we had an instance of SQL Server underneath our product. And we used that instance to validate our schema. Now, the problem is like we had an in-memory model, we had a representation in the database, and it wasn't really always in sync. And what we've done now is like we actually moved everything into a single representation, so all the tools work off a single representation. No more need for a local design database. Therefore, it's like also the install footprint is a lot smaller. And it's like actually we can guarantee the consistency of the results between schema compare and build and deploy, for example. We also moved all the comparison options that we had in schema compare into the build and deploy options. So we actually made schema compare a visual build environment. So if you want to do it visually, you can do it using schema compare. If you want to do it automated, you use the deployment engine. Now the other part that we've done is like we decoupled build and deploy. In V1, what I mean was that is 2005 and 2008 RTM. When you did a build, we needed to have connectivity to the target database. Most ISVs told us this is not a scenario that we can work from. We don't have that. It's like our customer database. We don't have connections to it. It's like we need to be able to do this on the fly. And we need to be able to distribute this outside the context of Visual Studio. So the main scenario here is to actually enable the deployment of database schemas outside the context of Visual Studio. So what we've done is we changed build so it generates an output format which we coined the DB schema file. And the DB schema file is an XML file containing everything in your declarative model. So it's the blueprint of your schema. Single file deployment. Of course, there is configuration information that comes with your schema. Things that you want to make dependent on your environment. Like your logins, right? It's like my logins today, or it's like my development logins, my QA logins, my production logins. These are all different. My file path is different. Right, all these things can be parameterized and fed into the deployment engine. And the deployment engine is a set of .NET assemblies which are 100% redistributable. So the goal is, and I will show you in a moment, that you can take your deployment, put them on a memory stick, take your memory stick, walk up to a server, and do a deployment outside of Visual Studio. So the key of this is around the whole concept of schema compilation. Right. So we already had introduced the database project. Inside the database project, we have those DDL artifacts. Right. For SQL Server, those are .SQL files. How do we get those? Well, most of you will start by a reverse engineer of an existing database schema. So at that point in time, what we do, we take read-only access to your database. we shred your schema, create those SQL files, and put them inside the project system. After that, it's like we have no relationship or connection to that database anymore. At that point in time, you're completely offline. And that's a big mental model change. Right? For most people who are used to make their changes inside SSMS, right, or in other connected tools, at this point in time, you're no longer connected to your database. You're in a source code only world. So any change you make is a source code change. Therefore, it doesn't affect the server at that point in time. Now, in order to give you feedback about the quality of what is going on, we actually load this information in that schema model that I was talking about. Right? And we constantly compile this. And when I say compile, we are actually parsing it for syntactical correctness. We're then interpreting it in terms of figuring out all the relationships between the objects. After we check that, it's like we have to validate the syntax or the schema. And what do I mean with that? There are certain rules in SQL Server. For example, if you have a DDL, an after trigger, and the table was replicated, those two things don't go together. Syntactically, those are two constructs that are perfectly legal. But these are contextual validation rules that we have to put in place to make sure that we actually warn you in case you're running into situations like that. So we do that in the background while you're working on your project, unless you actually call build. At build time, we freeze the model, we validate it, make sure it's stable, and once it's stable and there are no errors, we actually write out this DB schema file. This DB schema file is the persistence format that we can then start to feed into the deployment engine in the next step. Okay? So as I said, it's like while we're working on your source code, there are a couple of steps that we go through. We take your source code, we actually parse it. And for those of you who are in the need of a T-SQL parser, right, the T-SQL parser is a reusable component as part of our product. All right, SQL Server 2000, 2005, and 2008, full fidelity T-SQL parsing, okay, as a .NET object model. Those parsers reduce or return a code DOM representation. This is the programmatic representation that we work on inside the model. So if you want to create a table object yourself inside a designer, you can programmatically pony up a code DOM representation of table with the columns and the primary keys and the foreign keys, feed that to the script DOM generator and say, spit out the SQL. Right? So that's also a public component, right? Script DOM and code generator. So after we created the script DOM representation, we interpret it, we build up the model, and then we run the validation rules. All of these facilities are part of the mainline product. Okay? So let's look at this. So switching over to my demo machine, I have VS up and running. I'm going to create a new project. So there are a bunch of facilities built in here. So we reorganized the directory structure slightly since the previous release. So underneath the database projects, we now list the providers as we have them. So I told you we're moving to a provider model. Why is this important? Well, the reason why it's important is that we can now decouple the releases of Visual Studio and SQL Server. As I said, it's like the main reason why we're shipping now is that we are adding support for SQL Server 2008. Right? What we ultimately will get to is when SQL Server ships a new release, they can ship a new provider with the SQL Server release. Right? And that's what we'll get to in the next releases after this. SQL Server will ship a provider that plugs into this environment, and you don't have to update your VS world. It's like that provider slides in, and you have support for your new SQL Server environment. Right? So that way, we also hope to be more facilitative to you so you can actually continue to use your development environment even when you're adopting a new SQL Server database. Okay, so let's go. We'll build up a 2008 database project. You also see that we actually separated out database and server projects. This is, of course, a specific SQL Server thing, right, where there is a concept of objects that are server-wide and database-specific. So we have two organizational structures to actually deal with that. That goes beyond the scope of this presentation right now. So let's create our demo database. We'll call it PDCDB. Actually, PDC I like better. I don't know why. So we'll create a database, and what it will do is it will create our framework. Just an empty database shell here, or empty project. You will find the project artifacts, like the variables, deployment setting, permissions, and SQL Server settings are separated out as configuration files. And the reason why we did this is to actually allow you to make those customizations on an environment by environment basis. Right, these are completely configuration driven. So if you want to use different database settings in your development environment versus your QA environment versus your staging environment, this is how you can arrange this. Right? Single file that represents all your settings and can move them around. So let's bring some schema into this database. We'll do that through our import database. We'll use our good old friend Northwind for now. We'll simply say that we want to take everything, script it out. So this is that moment where we're connecting to the database and threading all your schema into those singleton artifacts. Okay? We're going through the system right now and pushing those files into the project system. Files are now in there. And if we would go to Solution Explorer, we can look and see that we have files in here for our tables, our keys, everything. Now, a lot of you and some of you who might not have seen the product before will say, like, well, wait a minute. Now I need to start remembering where all those files are. I'm not used to this. Well, this is why you actually get the schema representation, which we call schema view. Right? I told you it's like we're building up a model. Schema view is nothing more than a viewer, just like object browser, over those objects. All right, so if you go to the employees table, it's like employees have columns. And even though if you double click on employees, it's a source code representation, we show you in the tree view the materialized version of this schema. Okay? Now what do I mean with like all these background checks, etc.? So let's make an ignorant change. It's like I have a lazy developer and he wants to use the column name to print out his labels on his form. So he needs a space in here, right? I'm an ignorant developer right now. Okay? You don't have these guys in your org, I presume. So you hit save, okay? And you go to your, oops, I want to show the error list. Here's my error list. And it's like I hit save, and it's like immediately the system says, like, hey, you broke your system. You broke the build. All right? It tells me that it's like, I changed this index, and I didn't update the index. And I have a view here that I didn't update. Okay, so I should have updated all those places. But hey, I'm in an offline environment, so I can make ignorant changes like this because I didn't hurt anybody, right, as long as I didn't check it in. So let's undo this change and save it again. Errors go away. Okay, so how could I have done this? Well, one way would have been to go to my column and ask for all the dependencies on this object. Where is it being referenced? I could manually walk through all these objects and go fix them up. That's hard work. I don't want to do that. But we can give you that kind of dependencies at the column level. Right? Even though SQL Server 2008 has dependency tracking, where they have better dependencies between objects, they don't tell you at the column level what's going on. All right? So this is great if you also want to do an impact analysis of a change. Right, what if I'm going to change this column? Well, would it be nice to at least figure out it's like where this column is being used so you have at least some idea about what is going on in your system. So this is where places where you can use the schema view. All right, so let's dock this back. This is not the right real estate, but okay. All right, so that's one way we could have done this. The other way is to actually use this through refactoring, right? We build up our schema, and we can use refactoring to actually make a change in a holistic fashion in the context of our schema. So what this does is like it actually goes around and says like, oh, I'm going to make a change here. Like change it from with a space in it, so I need to go update my table. Well, I knew that. Need to go update my index, my proc, right, and all the places inside my system. Okay? So now I know where all these changes should go. And that's great. We'll do in a moment, we'll actually make this change effective. First of all, what I want to do is I want to go and deploy this database as it is right now. So without the change, I want to go and deploy this. So what I'm going to say is I'm going to my deployment options and pick where I want to deploy this to. I'm going to set my target connection. I have a local SQL Server 2008 database called SQL Server 100. My database name, I'm going to use PDC as the database name. And by default, we no longer deploy directly to your database. Right? The F5 scenario, right? It's like where people step through a solution. In the previous releases, like we actually did build and deploy to the database under F5. A lot of you told us, please don't do this. Right? It's like some people don't pay attention. It's like didn't have enough coffee yet. So what we did is like we actually built in this extra safety valve that says like we're only generating the change script for you. Right now it's like the database does not exist yet, so I'm going to push it to the database. And I'm going to say deploy. So what this will do, it will build out the DB schema file and push it to my database. Okay? So it will go, creating PDC, adding all the objects, and I'm done. All right? So now I've done that. I'll go back to my schema view and make that change that I was just trying to make. So I'm going to refactor once again. Last name. Going to say OK, same changes, apply. Okay? So now I have a database and a changed schema. Okay. So I'm going back to the slides for a moment, and then we'll go back and further deploy this information. So what we've seen so far is that we've built up our declarative model. We've built it. That results in the DB schema file. And now I'm getting to the point where I actually want to deploy this. We already did one deployment to just create the database, which is the easy case, right? Because like, well, this is what you want. You don't have anything, then it's easy to define what you want. However, if the database is in place and you need to start updating this, how is this working? So the first thing that we do is if you have your DB schema file in your target database, we create a model from each side. Right? At that point in time, we're going to take this information and compare it. So we're doing a model diff. Right? Same as schema compare. Right? The result of those diffs are actually being fed into the deployment engine. I would say, okay, that is great, but how do you deal with a renamed object? Right? We just did a rename. How does it actually feed into the system? How can I make sure that this information is deployed as I should deploy it? Because if you're a diffing-based engine, how do you distinguish a rename versus a drop add of a column that happens to have the same type? Right. This is where preservation of intent comes in, where we're actually helping the system through additional artifacts do the right thing. So we can feed in this information to the deployment engine to actually make certain that a rename is deployed as a rename, a move schema is deployed as a remove schema, and an add drop column is deployed as an add drop column. Perfect. Thank you very much for complimenting me here, or adding to me. It was not a compliment. Still my second language, English. So, the remark that was made, which is a very valid remark, right, is that we know this because you actually made this change through refactoring, right? And I'll show you in a moment what we actually did under the cover to actually help you and preserve this information in the system, and also make it available to your colleague who checked out your changes later in the day. Okay? So this information is being fed to the deployment engine, and then we will, by default, generate a .SQL file to update your target. That is the default instance. Now you can choose to actually go and update the database like I showed you. This is actually a pipeline of things that is extensible. So we actually have some plans to make other outputs available, like an auditing format, for example, to give you a change script that simply documents, these were all the changes that you have inside this script. All right, that way you also have some automatic documentation generation, because we know it's like if we don't generate the documentation never gets there. So build will completely validate the model before it does anything. It needs to make sure that everything in the model is consistent. And this is where the distinction between errors and warnings comes in. Right? If we detect that it's like you have an object inside a view that is missing, we will emit an error. Because like that is not a deployable thing. Right? If that same object would be referenced from a procedure, we would emit a warning. Because SQL Server has deferred name resolution, and it will allow us to actually deploy this artifact anyhow. So then we validate the pre and post deployment scripts. Now pre and post deployment scripts in this release, in the GDR release, are really that. They are your customization points to run code before and after the build. We no longer need them to do all sort of miscellaneous actions inside the system, because everything is modeled into the model. Then we serialize it to the DB schema file. Right? And with that, we generate a bunch of other files. If you're using SQL CMD variables, those are defined in the SQL CMD variable file. Deployment settings are separated out, and the settings files as well. All of this is held together through a file called the manifest file. And this is the file that actually allows us to do this one file deployment that you're going to create. Okay? And this, so we don't have to read it here, but this is just a placeholder where it's like we can hold all the information together. So now let's take our database and actually go and deploy this. So we're going to have our database here, and instead of doing this to the UI, which is like I don't want to do right now, I'm going to switch over to my good old mode, 3270 command line mode. In colorful black and green for those of you who love IBM. So I'm going to take my memory stick, put it in here, going there, and it's like there's nothing on there right now. Okay? So I'm going back to my C demo location where I have the PDC project. So here I have my PDC project. I have some build output in debug right now. So in here is like I have my SQL CMD variables, all the files, the deployment manifest, all the things that you saw described on my system. And what I'm going to do now is I'm going to say create deployment of the PDC database. And right now this is not 100% final. It's like I need to give it the output path. And then where do I want it? Well, it's like let's create a directory which we call deploy on the G drive. Okay? So what this will do is it will create my deployment instance. It will copy all the files that I need from my project output and the deployment engine onto my memory stick. Okay? So now I'm done. I take my drive, walk up to another server which I don't have here, so I stick it back in. Go to my memory stick. All right? I have my deploy directory. In my deploy directory, I find two directories, deploy, which holds all the runtime, the dbproj, which holds the project information, and then a command line tool, or a batch file that we created, which is called deploy. So let's do this, notepad, deploy CMD. And what this does, it calls the command line tool, which is called vsdb CMD. We're going to deploy, point it to the manifest file, that's it. So it will take all the information from the manifest file, but don't worry, everything in the manifest file can be overwritten from the command line. So if you want to point it to another database, another server, you want to create change some setting, you can always override from the command line, and the command line wins in that case. Okay? So you have total control here. So let's do this. Let's go and basically hit deploy, and we're going to push out this change to the system. And hopefully the demo gods are with me. All right, and it generates the pdc.sql file, notepad pdc.sql. All right, so here is our standard file. We set our set options. We create our environment variables, our SQL CMD variables. Go into our database. And then let's see. We didn't push out any changes. Ah. Nah. Okay. Sorry for that. Thank you for paying attention. I'm too eager to show this. Up. All right, let's do this again. All right, copy the files. The deployment generator at this point in time indeed overrides what is on the target. So, and then it says, like, all right, we're actually finding out that what we're deploying was a refactoring operation. All right? And we are renaming that object and that column called employees to last name with a space. And so instead of actually dropping and recreating, the deployment engine picks up the fact that we made this change to refactoring and pushes it out as such. All right? So now, how did it get there? Is the big question, right? So what happens is, like, when you do a refactoring operation, we actually create a transaction log entry that uniquely identifies the fact that you actually did this rename. We make that part of your project. It's going to be checked in. It's going to be picked up by the deployment engine. The deployment engine knows if it pushed it out or not, and therefore it's like it can deal with consecutive changes on top of this. All right. This is a huge step forward when it comes to deploying changes into your database. Okay. All right. So we deployed out our incremental change. We updated our schema. So let's go back to our world. So now we're going to step back from our deployment operations and move into our extensibility mode. So what we've done is, like, we created providers to actually slip under the architecture. So what happens underneath here is that we created this schema model, and the schema model is defined through these providers. So today is like we're shipping SQL Server 2005, 2000, and 2008. This will become a public extensibility point in the next release of Visual Studio 2010. At that point in time, we already announced in June at TechEd in the keynote that IBM will support DB2, and we're working with all the other major vendors who sadly enough couldn't be on stage because they're not ready yet. But believe me, it's like they will be there. All right? It's like, so at that point in time, this facilities, this functionality that I'm showing you right now for SQL Server will be available for other database vendors as well. All right? And allows you to do exactly the same thing. Now, once you have an environment like that and you have different databases inside this ecosystem, you need tooling to be aware of what kind of environment am I working in. This is where project feature extensibility comes in. This allows us to project in a contextual fashion what kind of tools are available to the user. And so this is something that will come online as well in 2010. And then we allow you to actually extend the existing system in our world. So how does that work from a big picture and a block diagram? So underneath, we have the schema model. So this is the lowest level API. This is just a .NET API. It has no affinity with Visual Studio whatsoever. It's like it's only there to model the environment. Then we have our project ecosystem. This is, of course, host depending. Right? This is Visual Studio that actually allows us to work with project system. This is where Solution Explorer, Schema View, the dependency viewer, and the editor comes in. Providers can add extensions on top of this. Right? Because the Schema View in Visual for SQL Server will look different than one for DB2, for example, right? Because they have different objects. DB2 needs to be able to deal with Java packages where we don't understand Java packages. Okay? On top of this, we have the project features. Right? The project features expose the functionality that is actually brought in by providers. As I said, it's like we are shipping 3 providers. That will remain our mode. It's like we will ship providers for the SQL Server or for the Microsoft data sources. And then we have third parties lined up to actually start delivering providers for other databases. This functionality is exposed through a tool set on top of this, like schema compare and data compare and database unit testing and refactoring. third-party designers, all these things can plug in on top of the schema model and extend this world. And not in a canonical way, because a lot of you think it's like, well, how is this possible? Because you get this lowest common denominator implementation, which is why it's like all these tools are actually providing you with the ability to distinguish the tool that you're working against and providing provider-specific extensions. So that's in a big, from a 100,000 level viewed, the overview of our architecture. So at the extension level, we can actually build our own data generators and test conditions. We could do that in V1. But in the GDR, we're adding 3 very important pieces that you can extend yourself. Your own T-SQL analysis rules. So if you have a need to actually analyze your schema and deploy rule sets on top of this, this is the way to go and do this. You can add your own refactoring types to the system. And a type is the kind of operation. Right? So imagine that you want to split a table. Right? And as already was mentioned before by the gentleman here in the front row, it's like once we do this through refactoring, we can add this additional information to the deployment pipeline. Right? And start coming up with better deployments and preserving the intent of the change that the developer or the user wanted to make. Right? We can also add refactoring targets. Now, a refactoring target is the information that you're changing. So imagine that you have a solution inside Visual Studio, and you have a reporting services solution in there as well with RDL files. You're changing the column, you're renaming your column, right? How cool would it be if you can push that same change into the RDL file, right, and update the RDL information? That is now possible, right? I'll show you actually with a simple text file example how we can do this. Okay? So now extensions have therefore access to a very extensive world. They can get access to the schema model, both the specific one as well as the agnostic one, the SQL Server schema model as well as the data schema model. It can get access to all the source code fragments, right, and the programmatic representation of this, the code DOM access, right, and it gets access to the complete token stream. So this way is like from a programming perspective, you can write those tools that actually manipulate the model in very different ways. All those extensions are exposed through base class implementations or through interfaces. And once you start writing those extensions, you need to register them into our environment. The way that you register things into our world is by writing an XML file. You write an XML file that accompanies the assembly that you provide. You drop the assembly in, you drop the XML file in, and your extension is alive. No need to do anything else. All right? So you write your XML file. We have a little naming convention. The only thing that you need to follow is that it ends with extensions.xml. Right, you drop that into our extensions directory, right, and then you add your assembly to this. And this is where you say is like if an extension is turned on or off. So let's go and do this. Right, let's build our own rule for our system. So I'm going to close this guy over here. I don't need him. So let's bring up a clean version of Visual Studio. And I'm going to open up an existing project out of the rules pack. Okay. So what we're going to do is we're going to write a static code analysis rule and deploy this to our system. So I said already, it's like the way that you make your extension available is by copying this, and that's what we're going to talk about first. We have a set of post-deployment steps that are actually going to take the XML file and the DLL that we're going to copy and push this into our extensions directory, and then we need to register the assembly in the GAG. Inside the XML file is nothing more than our name of the assembly, the type that we're implementing, and if it's turned on or turned off. That's all that's in there. Very simple, very straightforward. Okay? So let's compile this. The compilation and the building of the project will copy the files. So we can now hit F5 and step into our rule. And I'm going to show you the rule by basically debugging through it, because you're not here to see me write code, because that takes for ages. I'm a manager. All right, so I'm starting up my instance of Visual Studio. I still say SQL Server. I left that team in 90, I don't know when. Seems like I'm still there. Okay, so I have my instance open. I'm going to open up a little project. Let's open up Northwind proper. So I'm going to open it up. And right now it's like it breaks in the debugger because it's like, hey, the extension manager goes through the list of extensions and figures out, hey, you registered this extension. And so what I'm going to tell you is like what my name is. So I have a name. In this case, I'm following a naming convention called dbproj.pax.rules. This is our rules pack that we're going to publish on the dbproj.com site. We have a number. We have some descriptive information. We have a URL, like in case information comes back. Okay. So right now, we'll let it go. And so the system is up and running. Okay. So the extension manager loaded our extension. And now it's time for the extension to do something. So the rule that we wrote is a rule that will show up in the configuration screen. All right. That's called dbproj pax rules. And there's only one in there that says, like, find all the stored procedures that start with S beyond the bar. And we all know that that is like, you shouldn't be doing that, but still, if I had to pay everybody in this room that does it, I would be bankrupt. Okay? So let's add a procedure that actually does exactly that. So we're going to add a little test stored procedure to our system so we can see how it actually... So we call it S beyond the bar, not so smart. Okay. So that's all we need for now. It's like, that's fine. So, all right, we have our rule set. We can simply say it's like run code analysis, or you can do it through the run button here. So run code analysis. Hey, it will instantiate my class. All right, so we did that before. And then the next one, if we put our breakpoint one step further, is that we'll go through the elements in the list. I should have excluded something. Okay. This is not a smart move. That's why I said I named the stored procedure appropriately, not so smart. That reflected more on me than anything else. Okay, so the next step is actually to rule. The rule needs to answer the question, what do I support? What can I be used for? So in this case, the rule says, like, I understand procedures. Now, there is some logic here. It says, I understand I procedures. So it wants to know all the procedures in this project system. It could have said, I understand iSQL procedure, and then it will get all the SQL Server procedures. Or it could have said iSQL 100 procedure. In this case, it would only get the SQL Server 2008 procedures. All right. So this is to indicate when should the rule be fired, all right, to the rules engine. Now, okay, so let's go and let's remove this breakpoint because it will hit a couple of times. And then we'll go into the analyze method. And the analyze method is the body of what the rule should be doing. This is how we analyze the information. What gets fed into this function call is the element that we're being called on. So let's look at the SQL element. So in this case, it's the DBO new cluster, new customer order stored procedure. And we also get a reference to the schema model in case we want to look at contextual information, right? Because from the schema model, I can get to the source code representation and to all the other representations that I mentioned on the slide. So then I'm going to step through this. Okay? I'm going to create a list of problems. So the way that we report errors is that the invocation of the analysis returns back a list of problems that we then will show in the error list. Good practice makes us check if the element that we get is not null. I'm going to get and strip out all the parts. So this is going to return a string array that says like the schema name and the object name. Then I'm going to cast that into a stored procedure. I'm going to get to the element source. So I get to the source representation of this. All right, so here I can actually go find out what source code file it's stored into. what the file offset is, and all the other information go to the script DOM representation if I want to look at the script DOM representation. And then I want to close this guy. Okay. So I'm going to do a check. This only rule, of course, is interesting if the object lives in the DBO namespace, right? If it lives in DBO schema, otherwise it's like I should pass it. And then it should start with SB underbar. That needs to be lowercase. All right, so this case, we're fine. So let's wait for the guy to, remove this guy. Run through the system. All right, so now we found one that actually has a problem. We're going to create a little string, pass that back to the problem collection. Now, it's like in order to provide the right level of information inside the error list in terms of this file, this is the offset, we need to provide the offset information, which we can get from the script identifier in the token stream. So I'm telling them where the string starts and where it stops, add the problem to the list. Hopefully there are no more problems. All right. My error list should have an entry now, which it doesn't. Oops, because I unclicked warnings. So now I get my warning raised because I registered my rule as a warning. It's in this file. This is the file name. This is the line. If I double click on it, it takes me to the source code. So this way, this enables you to actually write a rule set, a set of rules to make their code better. Right? This is not to be anal. This is not to be stepping on people's toes or starting religious war about coding practices, but this is just to proactively find problems in your schema. All right? And so it's like we have about 82 rules that we figured out that we want to start pushing. It's like, as I said, it's like there is a new website that will be starting up that's called dbproj.com. There will be a rules pack on that. And that's where we will start pushing out rule sets on a regular basis, because this is not something that has to wait till we have a proper release ready. Okay? So this was a simple one. Are you ready for the next one then? All right. So this was a simple step. And let's look at how we can actually build a refactoring type. So refactoring is a little more complicated, I warn you. All right. So that's why Jason Clark, architect in my team, was kind enough to create this very nice animation to actually help you understand what is involved in actually being a refactoring type or a refactoring contributor. So first of all, it starts off with like what you saw me do inside the schema view, right? You right-click on it, you select an option, refactor, in this case, wildcard expansion. All right. So those entries in that list are there because the refactoring commands are being registered into the system. Now, in order to be a refactoring command and show up in that list, you don't need to be a vzip package. You're just an assembly, and we will register it for you, the same registration mechanism that we had before, that I showed you before. So the same thing applies to rules as what I said to refactoring types. A refactoring type expresses its abilities by implementing or overriding the isSupported method and saying it's like, I can handle stored procedures, I can handle tables, I can handle this object. So you can write very broad refactoring types or very narrow refactoring types based on that information. The refactoring command, once it's invoked through the UI and the user chooses this, will establish a relationship with the refactoring operation. This is the kind of change that you want to make. So this is what, for example, rename is a refactoring operation. All right. Now, in order for the operation to do something, it needs inputs. So it has contributor inputs that it's going to get. And these contributor inputs are establishing a relationship with the refactoring contributor. Now, why is this so complicated? Well, because each refactoring contributor is going to add change proposals to the list. All right? But the fact is like that if you start refactoring, it has this trickle down, because you're walking through the dependency chain. So changes will trigger changes. All right? So therefore, it's like you will have other contributors kicking in based on the types of artifacts that you're changing, because you might change a table that is going to cause the update of a view or a procedure, and all these things trigger through the system. So you have multiple contributors all adding up to this change proposal. So you end up with a set of change proposals that then is going to be displayed into this display window that you are familiar with inside Visual Studio. You're still there? Yeah. All right. So let's build it. All right. So let's stop this debug session. All right. And these samples will be available afterwards. Don't worry. Plus many more. So here we go. And here's our refactoring pack. And our refactoring pack is like we're going to actually show two things. First of all, we're going to show the type of refactoring, or the target, so we can actually push changes into something else as well. And this is done through this simple text refactoring contributor. All right. So this is going to kick off renames inside a file. And then we're going to have a little refactoring type here that allows us to uppercase a certain, the first character of a table name. I chose a very simple example here. Okay, so let's build it. We're going to do the same thing. It deploys it. It does the same thing. It builds it, copies the files, copies the XML file, etc. Okay, so let's put a breakpoint in our text target, and then in our change proposal. And we're going to start up a Visual Studio build to actually debug into our own rule. We're going to load up the same project, right? The Nordwinds 2008 project. All right. So it kicks off the type because it figures out that it's like it needs to register those. So we'll skip those for a moment. And all right, so we have our not so smart store procedure, which we'll leave there. All right, so I have my table called T1 here. All right. And I have a little text file here that uses the same string as I used before. Right? This is just a text file. Okay? So we're going to do two things here. First is like we're going to do the same change that we've done before and deployed actually successfully. We're going to the employees table, and in this case, change last name and make it last names. So it's like it's at least a little bit different. Okay. So this goes and runs through the system, and it's like I'm breaking actually in my contributor. So right now it's like I'm actually being called for a change list proposal inside my contributor, where I'm being asked to actually contribute information for all the text files. So what I'm going to do now is like I'm going to look in my solution for all the text files and put the input into the system, all right, and bring that back to my environment. So the end result of that action, implementing me a target, so this is the same result, but what you will see is that, hey, now there is this new node showing up that I can refactor into a text file in this case. Right? And since this is a custom contributor, it's like it's not checked by default. Right? You have to opt in. So now it's like, all right, you say, it's like, hey, dude, you didn't do anything. Well, because you didn't select me. Because if you select me, I'll change it for you. All right? So if I apply this, it's like the refactoring operation, and you see my editor changing. All right. So now it's like you can push those refactoring changes not just into the source code in your .SQL files, but if you have a specific target that you want to keep up to date, it's like you can go and push that change if you know how to. All right. So now the last one that I wanted to show you is a little refactoring that we wrote, which is called make first letter uppercase. This is the simplest one we could think of. So this guy is called T1, and the goal is that it's like ultimately becomes capital T1. So the first thing that we're going to add into is like we're going to step into the command, right? Because as I said, it's like the UI invokes the command. Right? That is what's being exposed to the UI. So this says like go execute this kind of case refactoring, we called it. So this will start off the whole chain of events and walk us through the system. Okay? So once we've walked through the system, and I'll let it go, it's like we're actually going to be pushed into the refactoring operation. So here we're entering the refactoring operation. And in the refactoring operation, we get information about the object and the project information that we're actually pushing through. We're getting the schema element out. All right, and we're going to feed that to the operation. That was the second box on the diagram. From there, it's like we're actually going to push that into the input contributor. So these are the parties that are going to contribute changes, right? This is how I get access to the data. And so once I've got access to the data, I'm going to create those change proposals, right? Keep going through the system. Now, it's like I'll be called multiple times here. Why? Because there are objects depending on the type of change that I'm making. All right, so I will go and walk through the depending changes. I have to analyze the script here. Once I've analyzed the script, create a casing reference input for the referenced information. And so I'll walk through the system a couple of times like this, get the dependency information, and then finally I get to the preview window. So now I'm at the point where it's like I collected all my change proposals, and once my change proposal is there, I have my table and my change from T1 lowercase to TK uppercase. All right, if I say apply, it's like my change is being made. All right, so this is how you can write, and it's like I'm not saying this is trivial, but it actually makes the product so much more appealing, right? Because like we can add a lot of functionality and kind of operations that users like you might do on a daily operation. Right, and we chose to invest in extensibility to, instead of like entering or adding one or two new refactoring types, we chose to step back and implement refactoring extensibility, which is unique for SQL Server or for Visual Studio. I do it again. So that you can actually, we can keep adding value to the system. All right, so that was our refactoring type and our demo part 2. So I hope you got that. So in summary, so database projects provide you with a way to, in a declarative fashion, state how you want to lay out your database schema. All right, we provide a deployment engine that you can then take the artifacts that you built in this project system and push them out into your environment. It's an extensible environment that you can add features to, but we can also start adding providers to later on in the game. So, and at the end of the day, what this enables is a much closer integration between the data tier developer and the app tier developer. And that's ultimately what our team is about. Right, getting the app tier developer closer to the data tier developer. Right, the kind of refactoring that I was showing you, pushing things into a text file, imagine that this was an EDM file, right? Or an SSDL file or a SQL metal file that you generated. So you made a schema change, and we automatically updated your metal files so we can actually push those artifacts directly back to the app tier developer so his code can keep running. That's ultimately where we're going with this product, right, and what my team is working on. So that said, it's like this is a slide with all the related content. It's like the RC is available right now. Right? I was not joking that it was like 90 minutes ago or something that we pushed it. It's like the internet site is down right now. I thought I had it. Yeah. No, I didn't open it up yet. Okay. So I have a blog on MSDN, GERD blog. For those of you who have, and it's like I totally glanced over this, but who have the existing database developer or the database edition or have the developer edition, we actually merged the SKUs as of Visual Studio 2010, and everybody who has a MSDN subscription is actually entitled to both SKUs right now as of October 1st. I'll get to there in a moment. Okay. So this information is on the blog. It's like there are lots of related sessions. Don't try to scribble them down. Just come and collect one of those cards on the back. We have the whole VSTS schedule where Cameron and Brian and Laurie and all the other folks from VSTS, you can see when we're speaking. Hands-on labs, there are a set of hands-on labs. We don't have hands-on labs. I'm sorry we were too late. It's not because, and so that's why where I want to end it. If you have questions, please use the mic. Otherwise, I will repeat the question. Otherwise, thank you very much for coming. I hope this was useful. You had a question, sir.
Could you briefly describe what do I have to do? I have development edition 2008, first pack 1, and I'm now happy that I got start
Okay. So,
database edition. But what are the steps that I have to go through in order to get to the DDR?
okay, so the question is, like, I have database or the developer edition. How do I get the database edition stuff installed? In this case, Gentleman's on SP1. So first of all, it's like you have to download from MSDN the additional SKU. I'm sorry.
3 gigabytes.
Yeah, I hear you. It's a big image. It's actually 4 gigabytes. We just put it on a diet. It's gained something. It's like I lost 20 kilos while I was doing the project. It's like it all went into the ISO. So you will have to download that. It's like then you install the database edition from that. It's like that is an additive install. It's like it will only, despite the fact that it's a huge download, which we only add. You're correct, 15 megabytes. That's the only way how I could make it available to you right now. Otherwise, you had to wait till 2010. So there are two options. We could have said it's like we're going to exclude you from this, or you have to go to some pain, I'm sorry about that, and install it this way.
And then I have to reapply SP1.
You have to reapply SP1.
And then install the DDR.
And then you install GDR after that.
Okay.
It's like if you go to my blog, it has the step-by-step stages for that. Yeah. It's the best we could do to make that available right now. As I said, the alternative was to say, it's like, well, it's going to merge in 2010. You have to wait till then. So, any other questions? Sir, go ahead.
Yeah, I was wondering. I saw on a slide, but I didn't hear anything about it in terms of including any kind of default data with the deployment.
Okay. So the question is about including data into the project. Right now, it's like you're correct that it's like we're dealing with the schema only. We have a project on its way to actually include the data into the deployment pipeline as well, and incrementally deploy the data. That will be an add-on that we're going to ship as a power tool on top of the GDR.
I have a question. First of all, I want to say this is probably one of the most useful sessions I have attended, and I'm going to see. So thank you very much for all
Thank
this. You. It took you so long, but better late than never, definitely.
We're only 30 people, sorry.
My question is, when we make change to refactoring or anything, and we need to push that to the integration stream and branch, the TFS. So how does that gonna work? Developer is gonna make changes into the development branch, rename it, but my build will be from the main integration branch. So is it all integrated within TFS as well? So, from a source code control perspective, we support every SSCI provider that is out there. Every SSCI source code control system has different ways of dealing with branching and merging and versioning. In TFS, we totally support the merging and branching streams that they have available. If you have PVCS that works differently, we work with that as well. Okay. So from a perspective of how this integrates into source code control, it just integrates into source code control as the regular way that you deal with this. Right? That's why we made such a big deal out of the fact that it's like we make those artifacts that said this was a rename and make them part of your project so they become part of source code control. So that information doesn't get lost when it is upstream in some version stream and needs to get deployed. Yeah, I mean, just to give an example of the two developers on different machines, and they are making renames to the same table or even different tables. But I'm going to deploy only one change. But the refactoring file is the same. So two comments. This is not a mitigation for source code merging. Right? If two people merge or change the same object, right, you have merge conflicts. Same concept applies here. It's like we're bringing schema into at the level of source code control. So it's like this is not a mitigation for
source code merge problems. Okay. Second of all, it's like the refactoring file, right, is something that is part of that merging strategy. It's like there is if you are picking up two changes, there are two transaction log entries that need to get merged into one, right? That is a merging activity, so you can actually keep those two separately.
Okay. And one last question is how the refactoring or how complex scenarios can it handle in terms of if I change the data type from integer to string or string to integer, would it be able to handle that, or it will throw an error at the runtime?
So there are two aspects to this question, I think. Aspect number one is like, can refactoring handle the type of operation? And it's like, yes, it can handle kind of operations like that. The more interesting question, however, I think, is can the deployment engine handle the results of the deployment? Right? When it comes to data migration right now, it's like by default, we're looking at what is possible from a SQL Server implicit conversion strategy. Right? That's how we always figure out. It's like once we cannot deploy that, it's like there is an explicit conversion path which needs to go to a copy table strategy. Otherwise, it's like we cannot deploy this without an intervention of injection code, which is where refactoring actually comes in and helps us inject that kind of information.
Thank you.
Okay. You're welcome. Sir.
Hi. Great presentation. Thanks for your time and effort. My question, I have actually two questions. We have a SQL CLR assemblies deployed. And if any changes happen to those SQL CLR deployed assemblies, how will this model detect a change? And how would it generate the necessary deployment script?
So the question is about SQL CLR object changes. And so there are a couple of changes that we made in the infrastructure. Is like database projects can now create a reference to an assembly. So we actually know that it's a deployable unit. But we now can pick up the file from disk instead of encoding it into a byte stream, which we had to do before. Once we know about the CLR objects, during the comparison step that I showed you on the slide, where we're building the two models from the project and the target database, we actually bring down the assembly from the database, compare the prototypes, the function prototypes of the assembly information to figure out if there was any prototype changes. Right? Because if that was the case, it's like we would have to drop the assembly on the target server and rebuild everything. Where if you state within the same function signatures, we can deploy this through an alter statement. So we'll try to figure out what the dependence, or if there are any signature changes on the function. If that is not the case, we will deploy it as an alter. Otherwise, we have to deploy it as a drop recreate.
And it does handle it?
That's being handled, yes.
Okay. My second question is, a lot of the developers are very used to writing alter procedures or any T-SQL code in SQL Management Studio. Mm-hmm. What are some of the best practices? Do you have any documentation or resources so we can hand it to the developers to follow?
I think that's the biggest area, to be honest, where we're lacking in terms of having a good jump start and best practices. I know the SQL Server team has a set of best practices and white papers, although those two sources have not come together. We are working on a best practices white paper that is not ready yet. You want to commit to it? He doesn't want to commit to it. But we're working on that, but we're not there yet. So
thank you.
We hear the request. It's like it's the number one question. So we hear you. We're working as hard as we can to actually satisfy that need, but it's like we're not there yet.
That was about the editor? I missed part of the
No, that was about best practices.
Actually,
best practice and
I
get
have
started.
A couple questions too.
Because a lot of the developers are not used to doing T-SQL code inside the Visual Studio.
Right, so it's
So
just an editor. Right. But you do have a query editor now in Visual Studio.
Well, I think that, so I'll get to your question, sir. I think the remark is also in the context of the difference between writing code and defining objects through a dialog set environment. So the designers. Right now, it's like we have one common designer, which is called T-SQL editor. That is another thing that we're working on, but it's like that is an out-of-band effort that we're starting right now. So I'll go to the question. This gentleman over there, he has been patiently waiting.
question is the following. For example, you have a table with data, and you decided to add another non-nullable columns. So, and because you not support any data coming with this in this upgrade, so how you going to handle this situation?
So the system will actually flag that if you are adding a non-nullable object without a default, that this by default is not deployable.
Okay.
Right? Because it's like you cannot add a non-nullable column to a table which has rows with not providing a default. SQL Server will simply not allow this.
Okay.
Right? So we will flag that situation and actually prevent you from deploying that change. Right? Because it's like SQL Server will not be able to handle it.
So basically, I don't have any choice to create default value, and after that, alter it any way I want it.
Correct. So declaratively defining your schema is not a cure to work around SQL Server limitations. At SQL Server, schema management has certain restrictions. It has a whopping 5 type of statements, right? You can drop, create, add a column at the end, right? Drop a column, change the type, and then you can rename. And that's sort of it. It's like SQL Server doesn't have a very extensive set of DDL manipulation statements. Now, I was part of the SQL Server team, and I always thought that we were very restrictive. Now I'm working with our partners and finding that it's like, actually, we're not that bad. So,
thank you. And another simple question. Do you have any kind of visual help to design schema? Because like looking on the tables as a list tree view is kind of useful, but it's not give you any information about what's the relationship. In the previous version of 2003.NET, it was Visio for Enterprise Architect. And you were able to reverse engineer and forward engineer, generate DDL this way. But after that, it was discontinued. And it's have a hard time, I still keep it, but it's have a hard time even to reverse engineer data from the SQL Server 2005.
We know. It's like we haven't been able to fix it. As I said, it's like we haven't been able to fix this. It's like we know there is a desire and a need out there for better designers, graphical designers, and both dialogue-based designers. We were right now have been busy like building up the architecture and the foundational pieces. This is next stop is going to be in that area, but we're not there yet.
Thank you.
Sorry, sir.
First, again, great talk. If kind of frustrations because where I work, we spent many years for creating a lot of this functionality and kind of internally for our own deployments. And it's kind of, well, how do you deal with validating the refactoring operations against the data? For instance, you added, if the refactor is you're adding a unique constraint on a field, but in the data, you have data that's not unique for that field in the table. How do you deal with this?
So those changes are actually implemented. We only know those kind of changes at part of the deployment part. So the deployment is wrapped inside a transaction. So it's like we don't know. It's like at source code design time, we don't have that logic, right? We don't know what your data looks like because like if you're pointing us to server A and then to server B, that situation might as well change.
Well, at this point, you already can know at least.
We only so what I'm trying to say is like we only would be able to know this at deployment time. Right? It's like we don't know at design time that you're making it that we can check. We cannot check this.
Obviously.
All right. So it's like right now, it's like the strategy is that it's like those kind of changes are actually wrapped inside a transaction and dealt with that way.
So
the system can be augmented by actually adding additional scripting in front or behind to deal with those kind of things. But it's like that is the customization that is like the user would have to do right now.
Thanks.